Hey everybody, welcome back to some fun stuff. I didn't put on top here, but now this is going to be our first discussion on quadratics. And I started off at the table of values because I wanted to show you and emphasize to you that there is a lot of the parts of quadratic equations where you find a lot of patterns. And part of our job is to take advantage of all those patterns that we get. Now, what we're going to do here is we're going to look at the second difference. We've done this a couple days in class already, but I wanted to make sure that there was a video that you had a reference to if you ever had any questions about that. Now, remember what the second difference is used for. This is to find the a value. I spelled that wrong. I apologize. Value of f of x is equal to ax squared. And I'm doing this on Thursday afternoon, and we found out that it didn't matter if it was just an x squared or an ax squared, but if it was ax squared plus bx plus c, which is the general form, then it works, and it works out just fine. Now, if I complete this table, I'm going to get a 9, 4, 1, 0, 1, 4, 9. Now here, when you start seeing the numbers repeating themselves, this is always going to be the case in a quadratic equation. The point that is directly in the middle, that doesn't repeat itself, I know I showed you this, I like to put a V by it. This point is called a vertex, and when we get into the graph and we get into different versions of it, this vertex here is going to be either the maximum point of the function or the minimum point of the function. And then everything is kind of symmetric on either side of the vertex. Now, to calculate the differences, when we were dealing with linear functions, we looked at the first difference. And the first difference was always constant, which was really nice. Because once the first difference is constant, we know that's a linear equation, because it's the first difference. But now, what I'm going to do is I'm going to take 9 minus 4. And I'm just going to take the difference of the y values. That's equal to a 5. Then I take 4 minus 1, which is equal to a 3. And then I take 1 minus 0, so I'm just taking the next one down, and that's equal to a 1. Hopefully you see a pattern already. We just have some odd numbers that we have going down. And that's for x squared. Doesn't always happen like that, but it happens in this case. 0 minus 1 is negative 1. That's the next odd number. So if you want to take a guess, the next one might be a negative 3. Let's check it out. 1 minus 4 is equal to negative 3. Hey, it worked. Then 4 minus 9 is just equal to negative 5. And if you look at this, we had 9 minus 4 here and 4 minus 9. We're doing the opposite. So logically, it would make sense that we'd be getting opposite answers. If we're doing 4 minus 1, 1 minus 4, we should get opposite answers. But now, the second difference is going to look at the differences between the first differences. So what I'm going to do is I'm going to take 5 minus 3, and that's equal to a 2. Then I'm going to take 3 minus 1, which is equal to a 2. Same thing. Then I'm going to take 1 minus 0, which is, no, not 1 minus 0. Sorry, I was looking at these. So it would be 5 minus 3, 3 minus 1, 1 minus a negative 1. So that's actually 1 plus 1, which is equal to a 2. And then we have negative 1 minus a negative 4. Sorry. A lot of distractions going on around me right now. It's actually negative 1 minus a negative 3. So negative 1 plus 3, which is 2, and negative 3 minus a negative 5, negative 3 minus a negative 5, which is 2 again. So our constant difference, our constant second difference is 2. So when f of x is equal to x squared, which is really equal to 1 times x squared, the difference is equal to 2. Now, let's try f of x is equal to, let's say, 5x squared. And I'm going to go x, and then I'm going to take some time, and you could do this. I'm going to do x squared, and then I'm going to go 5 times x squared. So it might be a little bit easier. And I'll do negative 3, negative 2, negative 1, 0, 1, 2, 3. So we'll have those. Now, just like the numbers up here, you get 9, 4, 1, 0, 1, 4, 9. Just using the numbers we already got. Now I just multiply by 5. 5 times 9 is 45. 5 times 4 is 20. 5 times 1 is 5. Not quite sure why I wanted to put a 20. 5 times 0 is 0. Remember, that's my vertex. 5 times 1 is 5. 5 times 4, 20. 5 times 9 is 45. Now, get your first difference. Look at the difference of your y values. 45 minus 20 is equal to 25. 20 minus 5 is equal to 15. Five minus 0 is 5. 0 minus 5 is negative 5. 5 minus 20 is negative 15. And 20 minus 45 is equal to negative 15. So now kind of looking at these, they're kind of all over the place. But hopefully you see the pattern. Because, remember, it's the second difference because we have an x squared that we care about. The second difference is going to be 25 minus 15, which is 10. Then we have 15 minus 5, which is 10. Then we have 5 minus a negative 5, which is 5 plus 5, which is 10. Then we have negative 5 minus a negative 15, so that's positive 15. That's a 10. That's a now we have a negative 15. That's minus 25. Minus a negative 25, which is 10. Now, so for f of x is equal to 5x squared, we got a second difference equal to 5. Now, so when f of x is equal to x squared, or 1 times x squared, the difference was, the second difference was 2. Now, the second difference is not 5, it's actually 10. Wow, I'm going to have to redo this one, but for now, I'll put this one up so at least you have something to start with, and I'll make them better. Now, here's the case. If I know the second difference, for this case, I know a is 1, and I know my second difference is equal to 2, how can I go from 2, do some type of math, and get 1, which is my a value? And to give you a hint, you're going to divide. 2 divided by 2 is 1. Now, if it's the same case, then how do I go from the second difference of 10 and get that to a 5, where a is equal to a 5? I take that 10, divide it by 2, and I got my a to be equal 5, which is the a on f of x. Now, here's this for a, it's going to be the second difference constant divided by 2. And in class we did an example of an x squared plus like 8x squared minus 16, and we found our second difference, and it ended up being exactly the same thing. Once we divide it by 2, we know what our a value is. We know that f of x, sorry, the pen went a little bit nuts there, is equal to ax squared. Whatever we get for that a, we can dump it in right there. So all we have to do is find that value for a, and we are good to go for second differences. I'm going to do a better video, but I wanted to get something up that reinforced what we did in class. So this is, like I said, our first way of examining not only the symmetry of what goes on, because here, even from the vertex, our answer goes 5, 20, 45, 5, 20, 45. This answer went from the vertex went 1, 4, 9, 1, 4, 9, and then we were able to find that difference. Here we were able to find that difference. So hopefully that's our first step in the right direction with quadratics.